Imagine you successfully build a time machine. You step inside, travel back several decades, and make a terrible mistake. You accidentally do something that prevents your grandparents from ever meeting. The domino effect of that single event is immediate. If your grandparents never meet, your parents are never born. And if your parents are never born, you are never born. But here is the logic knot. If you were never born, how could you have possibly built a time machine and traveled back to stop them from meeting in the first place? This scenario breaks a strict rule of physics known as causality. Causality simply means that a cause must happen before its effect. You cannot have a footprint without a foot to make it. This loop shows how traveling backward in time contradicts the basic rules of our universe. To make it work, we need to find a mathematical loophole in the laws of physics. Albert Einstein gave us a way to think about this when he described space. He realized that the space around us is not an empty, rigid box. It is more like a fabric that can actually bend and warp. Imagine the universe as a flat sheet of paper. If you want to travel from point A to point B, you draw a line straight across the surface. That represents a normal journey across space and time. But if space is a fabric, you can fold it. You bend the sheet so that point A touches point B. Now, instead of traveling across the whole surface, you can slip through a tiny tunnel connecting the two. We live in a three-dimensional world, of course, so the entrance to this shortcut wouldn't be a flat circle drawn on a map. It would look like a floating sphere. This diagram illustrates what physicists call an Einstein-Rosen bridge. You probably know it by its more popular name, a wormhole. By taking a shortcut through the folded fabric of space, the math suggests you could outpace a beam of light. Under the right conditions, it provides a physical path to travel into the past. There is a major catch. A natural wormhole comes with incredibly intense gravity. That gravity pulls inward so violently that the tunnel pinches off and collapses in an instant. Any traveler attempting to cross the bridge would be crushed before making it even a fraction of the way through. To prop the tunnel open, you need a material that does the exact opposite of normal gravity. Instead of pulling inward, it has a negative energy density that pushes outward. Physicists call this exotic matter. We haven't found actual exotic matter in deep space yet. However, in 2015, researchers managed to simulate the math of a wormhole by creating a tiny magnetic illusion in a lab. They successfully made a magnetic field vanish in one location and instantly reappear in another, mimicking how a true wormhole would operate. The math holds up on a microscopic scale. But engineering a massive, traversable tunnel for a human means gathering theoretical exotic matter that defies the physics we interact with every day. Let's assume you manage it. You gather the exotic matter, stabilize the wormhole, travel back to your grandparents' era, and interrupt their meeting. How do you survive the paradox? Quantum physics offers a potential answer, found in something called the many worlds interpretation. Stepping through that wormhole might not drop you into your own history. Instead, it places you into an identical, parallel universe. Because you are in a new timeline, you can stop this version of your grandparents' meeting. Your original timeline continues to exist, completely untouched. You bypass the logical trap of the grandfather paradox entirely, but the price is leaving your home universe behind forever. Alternate dimensions provide a neat mathematical escape route, but our physical universe seems to have a severe allergy to traveling backward in time. The physicist Stephen Hawking suspected the universe actively defends itself against these paradoxes. He called his idea chronology protection. Hawking pointed out that space is full of microscopic temporary particles. If a time loop opened up, these invisible particles would rush through the shortcut. They would pass through the wormhole, exit into the past, and circle back through the entrance again. They would make this loop billions of times a second, building up infinite energy until they blow the wormhole completely apart. Before a single human could attempt the journey, the tunnel would destroy itself. The universe appears to have a built-in defense mechanism, leaving trips to the past exactly where they are right now, safe on the chalkboard.